Hi students, today we're going to talk about Le Chatelier's principle. And Le Chatelier's principle says if a stress is applied to a system in equilibrium, the system shifts in the direction that relieves the stress. And a stress can be any kind of change in the system that upsets the equilibrium. In our notes, we're going to talk about shifting right or shifting left. And shifting right means it's shifting towards the products, which means it makes more products. Just remember, we've got our reactants on the left and our products on the right. And then if we shift to the left, we're going to shift towards, if we're shifting to the left, we're going to make more reactants because we're shifting towards the reactants. So these are 5 different ways we can change or add a stress of some sort to a system that's at equilibrium. So if we add reactants or products, if you add substances involved in the reaction, it always makes this reaction shift to the opposite side of the addition. So if you add reactants, the reaction is going to shift to the right. If you add products, it will shift to the left. And so this kind of shows you what's going on. You can think of equilibrium as a seesaw. And so if these are our reactants and these are our products, if we increase our reactant A, what's going to happen to the seesaw? Well, it goes down because there's more of it. And we want to shift back to that equilibrium position. So to shift back to that equilibrium position, what happens is we need to create more products to get it back to the equilibrium so that it counteracts that addition of A, so that we have more C and D, so it counteracts that addition of A. Removing is the exact opposite. So if you remove a reactant or product, you're going to remove substances involved in the reaction, always make the reaction shift to the same side of the removal. So if you take something away from it, if you're thinking of that seesaw, if you take something away from it, you would have less of this. And so then you need to add more of it to get back to that equilibrium. Changing volume. So changing volume, you want to count the number of gas molecules on each side of the reaction. If you decrease the volume, the system is going to shift towards the side with more gas molecules. Oh, I totally lie. Less gas molecules. I didn't register that it was decreasing. If gas molecules are equal, there is no shift. So decreasing goes with less. If you are increasing the volume, the system's going to shift towards the side with more gas molecules. And if the gas molecules again are equal, there is no shift. Changing a temperature, so changing heat. Treat heat as a reactant for endothermic reactions, and then follow your adding or removing up above. Because remember from last unit, your heat is a reactant in endothermic, and then treat heat as a product for exothermic. So remember, heat's a product for exothermic, and then treat it as if you're adding them or removing them. If you add a catalyst or any substance not in the reaction, it has no effect on equilibrium. So it would always be no shift. So I know that was a lot, so we're going to practice. If you think you kind of got this, pause and see if you can do it on your own. Otherwise, we're going to practice this. So in which direction will the position of the equilibrium be shifted for each of the following changes? So the first one is O2 being removed. So O2, if we decrease this O2, that means you're removing that reactant. If you remove substances involved in the reaction, they always shift to the same side of the removal. So if you remove the reactant, since it's on the left, it's going to shift towards that. So the reaction is going to shift left. When the volume is increased, so volume is here. When volume is increased, we want to count the number of gas molecules on each side, and it's going to shift towards the side with more gas molecules. So in this reaction, I see 1, 2, and 3. So 3 gas molecules going to over here. We just have that 2, so it's going to 2 gas molecules. So we want to increase it, so it needs to go to the side with more. We have more gas molecules on the left, so it's going to shift left. And then we're going to decrease the temperature. So decreasing the temperature is this one. I kind of should maybe do some colors. O2 removed. Let's do a different color so we know what's going on. Okay, so temperature is decreased. This is going down. So that's like removing the heat. And so we are removing it, and heat is on the right, so it's going to be like a product. So if we remove products, the reaction shifts to the right. An inert gas, neon, is added. So an inert gas, neon, is not in this reaction. So that's any substance not in the reaction. And so this will have no effect, so we're going to write no shift.